Please welcome Executive Director at the Center for Amazonian Scientific Innovation, CINCIA, and Research Assistant Professor, Department of Biology, Wake Forest University, Luis E. Fernandez.
Hi, everyone. I was invited here today to talk about our work in the Peruvian Amazon. I'm a tropical ecologist. I was born in New York City, which is as far away as from a forest as you can imagine. I played in empty lots that had trees of heaven, if you've ever been there, basically weed lots. But for me, that was my Amazon. My mother's from Ecuador, my father's from Cuba, so I had a connection to at least visit one when I was a child. And when I did, it was really eye-opening. And I always wanted to do something for a living that allowed me to be there. The place I work in now is such a place. It is Madre de Dios, close to the triple border between Bolivia, Brazil, and Peru. It's known as the capital of biodiversity. Alex spoke very eloquently about the places that are special in this area. And it really is. It's one of the most beautiful places to me. It's a place of sublime beauty where large rivers cut through huge swaths of forests filled with not only animals and plants, but people. But it's also a place where you have no cars, you have boats to get around, and small villages instead of large cities. But in these places, there's also mining that has come in for many different reasons. But it's come in fast. It's brought many people that are searching for a better life, very similar to where we are now in California, the Golden State, where people came from around our country in its youth to find jobs, as they are in Peru, where people in the Andes are searching for a better life, or at least sending young men to get enough money to send back to their families. But to do so, they go into an area that has been transformed, where tens of thousands of miners start to go into areas which are essentially or quite literally protected areas, and they're using ancient technology. There's not very much difference from the type of mining that's done today to what was done here in California, Nevada, 150, 160 years ago, using high-pressure water hoses to liquefy entire riverbanks into a slurry that's processed using mercury. Again, a product of something very close by with the new Almaden mines just a few miles away. It's even a state park if you want to visit. But there it's something that you can literally touch if you just go and pay a couple dollars for a bottle of it. And it's used in a way that would scare most of us, where a broken thermometer elicits the visit from an entire fire department. People put it in 55-gallon drums, and they become human blenders, stepping on a mix of mercury, gold and mercury-containing sands for hours to produce a concentrate that literally is silver gold. It's a mixture of mercury and gold, the amalgam, and people, this for them is normal because it represents a better future. After processing it very simply with a blowtorch, you then get gold, earning 10 or 100 times in one day that your family could earn if you're a poor farmer in a month. So that's the start of my story as a scientist in this region. I'm the executive director of CINCIA, Centro de Innovación Científica Amazónica, the Center for Amazonian Scientific Innovation. And I see some of our colleagues here that work with us in Peru. Thank you for coming. But we are a collection of biologists, chemists, fish specialists, communication specialists. And we do lots of things, some of them with technical fancy names, but actually what we do is we ask the question, what is the cost of artisanal gold mining in the Amazon? More specifically, what's the cost of forests, the cost of watersheds, the costs to biodiversity, the costs to public health, and the costs to native communities that still live in this region in traditional ways. And also, what is the cost of ecological restoration of this kind of mining in the Amazon? So we're going to go back to that forest that's changing very rapidly, where we see the edges receding away from us, where forests are disappearing and what's left is a very different landscape. No, sometimes when you go down on floor level, you can't even believe that this was just a forest a couple months before. And in some cases, the forest completely disappears and it becomes a body of water filled with sediment and in many cases, mercury. So what we need to do is create innovations. And we're scientists, so we think what new tools and different ways of collecting the data to do our work. We use drones. Drones are very popular, but essentially what they are eyes in the sky for us to be able to see things. We bring down specialists and we've formed a team of 20 people that use custom-made drones to fly in areas where no one has really seen because they were blocked off. They were very dangerous to work in, and just recently the military went in under the special state of emergency, and now we are doing surveys of this area to understand what is going on, what has been lost, what's been left behind, what can be recovered. We start these flights, and what we see is a landscape that was forest and now is a mixture of sand and water. What we can start to do is not just take pretty pictures or scary pictures and videos, but treat this as data, where we start to do the things that our cell phones do for us every day. Something similar to facial recognition. We're using machine learning to start to process much of this imagery to identify mining equipment in an automated fashion so we can start to find out where things are and have early alerts. We can also start to use satellite radar data to see where the water is and see really how much has been transformed from forests to water, from forests to sand. We can piece together the history of loss. This is an image that was published in a paper where we go back to 1985 with satellite imagery every year, and we see what happened. And that gives us an insight into what could be happening in the future if this is not controlled. We can see how the mining deforestation relates to the price of gold, which that line there is really tightly related to the amount of deforestation. When the price of gold goes up, deforestation goes up. Our demand controls that line. If we want more gold, more rainforests will disappear and more biodiversity will die. In Mano de Dios, 300,000 acres has been destroyed of primary rainforest. We also see that between 20 and 25% of the land has been converted to mining ponds. It's converted to water, which means it will never reforest, at least in our lifetimes. And what is in that water is another set of questions, which we use another type of drone to start to take samples and answer. We roll up in one of those modified three-wheel carts that Alex was bouncing around in, and we bring submersible drones, basically water drones, to go into these areas to take samples, to use sonar to map out to better understand this. We also do it the old-fashioned way. This is a hollowed-out canoe made from one tree, where we take cores. We fish as well and elicit the help of villagers. It's a young boy with a dorado, which is one of the largest catfish that has 1,500-kilometer range from, similar to the salmon, traveling to the Amazon's mouth and back. We take tissue samples. And we even go to the markets, buy fish that people eat in cities 200 kilometers away from the mining zone and test it for mercury. We take these samples, we bring them to a lab we established, LAMCA, the first environmental mercury laboratory in Peru, simply because I got tired of bringing back the samples in my bag to the lab here at Carnegie, just a few miles away in Palo Alto. So we brought the mountain to Muhammad, essentially, where we formed the first mercury lab because we needed to. And we put it in the rainforest, where people told us, you can never do that. It's impossible to have a top quality lab. We did it. And now we have one of the largest programs in the Americas evaluating mercury impact in aquatic systems and across plankton, macroinvertebrates, fish, sediments, but also have the ability to measure mercury in air, where using very innovative low-cost methods developed, in this case with the colleagues from the University of Toronto, which are essentially small cold cream tubs. We have very sensitive mercury sorbents that absorb mercury in the air. We can take these measurements, we put them all over cities, and that transforms into hotspot maps, where we can detect where illegal and clandestine emissions of mercury occur in people's houses when they burn mercury in their backyards, or they have little businesses which are not allowed. Making the invisible visible, essentially, is what we do. We also work with villages very far away. This is a community in Manu National Park, about 2 days upriver. And we take hair samples because hair is the best way to assess mercury that you eat from fish, methyl mercury. It's the same mercury that's in your tuna fish or swordfish, which you should be eating sometimes or too much of. Especially with children and pregnant women, they're extremely vulnerable. We provide basic health care when we visit these communities. Most of these communities are only 30 or 40 years out of initial contact. And we brought neurological specialists to start the testing for cognitive effects, neurological effects on these highly exposed populations, and provide their results back to them in ways that they can better understand. It's difficult. They're 30 years out of contact, but they deserve to know what the risks are for the food that they eat. Notice the monkey on the boy's back. My favorite picture. But right now, Madre Dios is releasing, until recently, until the mining interdictions, 185 tons of mercury per year into the rivers and lakes of this region. That has resulted in studies that we conducted in 2013. 7 of 10 people have mercury levels above the US EPA recommendations. 6 of 10 children. And 7 of the 10 communities with the highest levels of mercury were indigenous. So this mercury is a neurotoxin, so this could be creating potentially a generation of children and then adults that have neurological deficiency. Of course, we have to talk about the forest and what was lost. What we need to do is understand how can we reforest areas which are essentially sand and may be contaminated with toxic mercury. Reforestation is one of our major goals, and we've done a lot in testing how we can do this, using the knowledge that we see from natural regeneration, how forests return from landslides and when the rivers kind of drown out beaches, river beaches, the forest comes back. We started to look at that and we learned from how Mother Nature does it, which species, what conditions, so then we can start to think creatively. This is Brazil nut husks. There's lots of it because this is a major center for Brazil nut production. And we basically MacGyvered the creation of the use of biochar, which is a special type of highly stable charcoal, which is really good because it has lots of carbon, allows for microorganisms to attach to it and increase soil productivity. We basically take about 10 of these things, put the Brazil nut husks in them, set them on fire in a slow and controlled way. It's the way you do it, not just the fact that you do it, and we create tons and tons of it. To date, over 45 tons of this material has been used for planting trees in a series of experimental plots. We test 60 species of native Amazonian trees and 120 acres of experimental plots. It's the largest reforestation experiment in the Americas because we need to know under what conditions and how much does it cost. So just a couple more words. It's not just science that needs to be innovative, it needs to be communication. Typically, scientists produce scientific papers and reports. That's great for scientists and for some policymakers, but we really need to be more creative. We're trying to be better at using Twitter. Twitter doesn't have the best uses nowadays, perhaps, but it is very effective to get to different people that don't read these highly technical reports. And of course, something that everybody can use. Information that's useful, that's colorful, that's easily understandable, so much so that a child can use it. And these are students in Puerto Maldonado that are now learning about Mercury in their classes from K through 12. So I hope that in the future, with much of the innovations that will come, I'm hopeful, from this grand challenge, that terrible but beautiful landscapes like this, the mining zone, can be converted to something a little more natural, which is where I hope to return and see more of this in the coming decades. Thank you very much.